Alrighty, in this video here, we're going to be talking about 1.3, which is properties of exponents. Alrighty, so mainly, if you see anything to a power, so we have a to the n, it just represents that we have that many times of that value being multiplied n times. That's what the book says, but in reality, this is what it is. So x squared is the same thing as x times x. X cubed be the same thing as x times x times x. X to the fourth, same thing as x times x times x times x. So whatever the power is, that's how many times you're going to multiply that. And that's really what that exponent represents. All right, the next thing is the what does a x to the 0 mean? So anything that's raised to a 0 is always going to equal 1 regardless. This doesn't exist. 0 to the 0 is undefined. And I'll explain this rule a little bit later. The next rule you need to know is anything raised to the negative of that, I can, what I say, flip the fraction and now make it a positive. But it just means if it's a negative, that's just how many of those you have on the denominator instead of on the numerator side. And again, I can explain that just about right now. All right, so the rest of your properties. So those are some just minor things. But the rest of your properties here are basically stating if I have a times n, and I have so a to the n times a to the m, anytime these bases are the same, I can just add the exponent. So this would be the same thing as a to the n plus m. So for example, x squared times x cubed will just be x 2 plus 3, which is x to the fifth. I do the same thing in a sense with subtraction. If I have a to the n minus m, sorry, my bad. When when I multiply and I add the exponents, when I divide like bases, I'm going to subtract the exponents. So for example, I could have x to the fifth over x cubed, and that would be the same thing as x 5 minus 3, which will give me x squared. The next one again, I'll write it, is anything to the negative exponent. I can just flip the fraction. One thing I also want to caution you is if I have it like this as well, I can still rewrite this as this. So notice the negative, I flip the fraction and I make it positive. If it's on the bottom, I can flip the fraction and now put it on the top. Anytime you have a power raised to a power, you will multiply. So when I multiply like bases, I add, divide, I subtract. A negative, I flip the fraction. A power to a power, I multiply. Same process works when you are distributing. It would go to every single factor inside the term. So that'd be a to the m and b to the m. Same thing applies in division. So this would be a to the m over b to the m. All right, now I wanted to kind of just throw some over here. Why does x to the 0 equal 1? Well, now knowing these rules, x squared over x squared, you know that equals 1. But if you apply these rules, that'd be 2 minus 2, which is 0. So using what we know and then using the rules to apply, we can see that we can prove that x to the 0 does in fact equal 1. So this is just a little note. All you gotta do is just memorize anything to the zero is equal to one. You don't ever have to show it, but I usually have a lot of students that ask that question. Next big thing in this, though, is what we call scientific notation, learned in your science courses, but they kind of expect us to teach it to you as well. And it comes a lot with our exponent powers, but basically it's just written as a times 10 to some power n. A big thing to note is the absolute value of a has to be less than or between 1 and 10. It can be 1, but it has to be less than 10. All righty. I mean, the a can be a negative. It just has to be between negative 10 and negative 1. All right, and that's pretty much the gist of 1.3. So let's just get into some exercises so that you are familiar on how to do all these things. So let's look at exercise 1. In this set, it says simplify each of the following expressions, writing your answer with only positive exponents. So in example 1 on page 37, nope, I lied, 36, close enough though. This will be negative 2 to the fourth power. All right, so again, this just simply means negative 2 times negative 2 times negative 2 times negative 2. So work it out. Negative 2 times negative 2 is 4, times negative 2 again is negative 8, times negative 2 again is 16. Okay? Or you could do 4 and 4, um, and you would get 16 that way as well. So that right there, give me this. This times this, give me this. And then this times this. So if you didn't follow my thought process there. All right, let's look at number 2. Negative 2 to the fourth power. Again, notice that there's no parentheses, so the 4 only applies to the negative. So it's negative, and then it's 2 times 2 times 2 times 2, which will then be this right here is just 16, and then you apply the negative. So again, big difference between with parentheses and no parentheses. All right, let's look at example 8. Example 8 says negative 3 cubed. So this would be negative 3 times negative 3 times negative 3. So negative 3 times negative 3 gives me 9. 9 times negative 3 gives me negative 27. All right. Let's look at some more. So that was number 8. Let's look at number 9. So this would be 8 squared divided by 4 cubed. So again, just like I told you in order operations, you want to work the numerator and the denominator as two separate questions and then bring them back. So 8 squared would be the same thing as 8 times 8, and 4 cubed is the same thing as 4 times 4 times 4. So 8 times 8 is 64. 4 times 4 is 16. 16 times 4 is 64. So therefore we get 64 divided by 64, which in this case is equal to 1. Let's look at number 11. We get 7 to the fourth divided by 7 to the fifth. I'm going to pause here, and I could do this as 7 times 7 times 7 times 7, and then go on the flip side, do 7 times 7 times 7 times 7 times 7, work it out, and then simplify. Or we can apply our rules. We can apply our rules now because the bases are the same. So if the bases are the same, I can write the base and then just subtract the exponents when I'm dividing. So in this case, that's 4 minus 5, which gives me negative 1. Also applying the negative property rule, if I have a negative exponent, I can flip the fraction and write it as a positive. Now, we don't necessarily write the 1, so my final answer would be 1/7. A lot easier than doing 7 times itself 4 times and then times itself 5 times and then simplifying that fraction. Doable process, way easier if we apply our rules. Let's look at number 12. Number 12, we have n squared times n to the fifth. Again, applying our rules, the bases are the same, so I write it down once, and then because I'm multiplying, I will add the exponents. So 2 plus 5 gives me 7. So my final answer here is n to the seventh. All right, let's look at one more in this set. So that's number 14. I'm giving y cubed times y8 divided by y squared. So again, just like in order operations, I want to simplify the numerator and the denominator first before trying to simplify. So in the top part, I'm multiplying like basis, so I'm going to add the exponent. So this becomes y to the 3 plus 8 over y squared. So that would give me y to the 11th over y squared. Now I can apply the next property. When I'm dividing like bases, I will subtract the exponents. So this will give me y to the 11th minus 2, which will give me y 9th. Alrighty. Let's look at another set. So let's look at number 16. It says use the property of exponents to simplify each of the following expressions, writing your answers with only positive exponents. So we are given 3t to the negative 2 over t cubed. All right, so simplify it the way I like to break this down. Right now it's not as complicated, but it does get more complicated. Separate all your coefficients and all of your separate letters once the numerator and denominator have been simplified as is. After that, now apply. So 3 over 1 just stays 3. And then now with this like basis, I can subtract the exponent. So that would be negative 2 minus 3. So in this case, that would give me negative 5. Then I look at my final answer and I go, all right, this has a negative in it. So the term or the factor with the negative exponent will go to the bottom. Anything that does not have a negative exponent will remain on top. So this now becomes 3 over t to the fifth. I find this process to be the most organized because you always end up with not a fraction and only deal with a fraction if at the very end you still have a negative exponent. All right, so let's do some more to get some more practice in. So this would be negative 2 times y to the 0. Again, the 0 is only being applied to the 0 is being applied to the y only. So therefore, remembering anything that's raised to the 0 other than 0 itself is just equal to 1. So I'm going to write this as negative 2 times 1. Again, that 0 is only being applied to the y, not the entire thing. So then negative 2 times 1 gives me negative 2. So now looking at 18, I'm going to look at 1 over 7x to the negative fifth. Again, it's pretty much already simplified, but we see we still have a negative exponent. So that negative exponent, again, I'm going to flip over that fraction bar, but only the factor that has the negative exponent. Notice again, the 7 is remaining there. So I now got 1x to the positive fifth, because when you move across that division bar, the negative goes away. And it's over 7. Now, we don't necessarily write this 1, so your final answer is x to the fifth over 7. All right, so let's look at some more complicated ones now. So let's look at number 27. So number 27 says x squared y to the negative second over x to the negative 1 y to the negative fifth. So this one I was saying that if you separate your information, once the numerator and denominator are pretty much simplified, there's no multiple of that same letter. Basically, get it down to just one of those letters. And then I'm going to separate. I'm going to separate as my x's and separate as my y's. So when I do this, like basis, I'm going to subtract the exponent. So in this case, that's 2 minus negative 1. And then I have a y, and it's going to be negative 2 minus negative 5. So in this case, two negatives make a positive. So I have really 2 plus 1, so that's x to the third. And this one I really have negative 2 plus 5, so that is actually y to the third. So this would be my final answer. So again, notice I'm avoiding fractions until I have to, only if there's a negative exponent, just to keep your life a little bit simpler. All right, let's look at number 30 then. So in this one, I have 3 to the negative fifth over 3 to the negative fourth, x to the fifth, y to the fourth squared. All right, so again, before you can separate it, you do have to simplify both the numerator and the denominator. Numerator is good to go, but the denominator, I need to get rid of this exponent. I cannot have double exponents here, so I need to apply it to each exponent. So in each exponent, it's going to be multiplied. So a power raised to a power, we multiply. So here we go. That's going to be 3 to the negative fifths. And then it's going to be negative 4 times 2, which is negative 8. 5 times 2, which is 10. 4 times 2, which is 8. Now, again, I'm going to separate my information. So there's my 3's, my x's, and my y's. All right, so in this case, I get 3, and that's negative 5 minus negative 8. Now, on this situation, I will keep a fraction only because there's no other letters on the top. So therefore, my letters must be on the bottom. Unless they're negative, and that'll be a different story. But in this case, I'm just going to write it as is. And now I'm going to clean up the top. 2 negatives make a positive. So negative 5 plus 8 actually gives me 3. And then it does want you to work that out. So 3 times 3 is 9 times 3 again. So I actually get 27 over x10, y8. So this will be your final result there. All right, next one I'm going to do is number 31. I get negative 9 raised to the 0 times x squared y to the negative second power raised to the negative 3 divided by 3x to the negative 4y. Okay, got it all written down. So again, I need to simplify both the numerator and the denominator before I can start splitting things up. I notice a 0 being applied to the 9, so that's going to tell me that's going to be negative 1 because anything raised to the 0 is 1, but only to the 9, not to the negative. This next one, I need to distribute this negative 3 out, so it's going to be x. 2 times negative 3 gives me negative 6. Negative 2 times negative 3 gives me positive 6. And then the bottom is pretty much already simplified. So now at this point, I can separate. Negative 1/3 is just negative 1/3, so I am going to have to deal with a fraction just because I couldn't simplify there. But my letters, not so much. Not right now, at least. So again, like bases, I can subtract. So that's going to be negative 6 minus negative 4. And then my y's, you might be going, well, what exponent's here? If you have a letter, there's an imaginary 1 if there's no exponents. If the exponent is 0, you wouldn't even see the letter. So in this case, that'd be 6 minus 1. So now I'm going to simplify this. 2 negatives give me a positive, so negative 6 plus 4 actually gives me negative 2, and then 6 minus 1 gives me 5. So again, looking at this, I notice that the x factor with the negative exponent is the only one with the negative, so I'm going to bring it to the bottom. Everything else is good. Coefficients can be negative, just not exponents. So my final answer here would be negative 1 y to the fifth over 3x to the second power. And I would probably accept this. However, they probably don't want that 1 either. So that would actually be negative y to the fifth over 3x squared. So being an online course, we do got to make sure we're keeping the online part happy. So again, that 1 is not necessary. All right, so let's look at number 32. Again, trying to see every one that you might see that could be difficult. So this one is a bracket, parentheses, 2x to the negative 1, z cubed, parentheses, negative 2, bracket, negative 1. All right, so in grouping, you need to do the most inner first and then kind of work yourself out. So there's nothing to do inside, so I'm going to take this negative 2 and I'm going to work it inside. Notice here, though, this 2 is a factor and does have an exponent of 1, so make sure you apply it to its exponent too. So coefficients, again, are factors. So here we go. So that'd be 2. 1 times negative 2 gives me negative 2. Negative 1 times negative 2 gives me positive 2. 3 times negative 2 gives me negative 6. And then now take this negative 1 and apply it to each one of those again. So that's going to be 2 to the second power, because negative 2 times negative 1 is positive 2. 2 to the times negative 1 would be negative 2. And then negative 6 times negative 1 would actually be positive 6. So now that I'm at this point, I just want to make sure I take any negative exponents and I bring it to the bottom of the fraction. And then I work out any exponents. So 2 squared would be 4z6, because now the x is on the bottom of the fraction. All right, so I hope that's enough examples, but I can always do more. Just let me know. Let's jump to another type of question. So let's look at number 49. So in this next set, it just simply says convert each number from scientific notation to standard notation or vice versa. So on 49, we are given negative 1.76 times 10 to the negative fifth, and we want to convert to standard. Standard form is just the number actually written out fully. Scientific is written as a times 10 to some power n. All right, one thing to note here, when you have a negative exponent, move decimal to the left that many times. So I'm going to take the negative 1.76 real quick, and I'm going to move that decimal 5 times to the left. So that's going to be 1, 2, 3, 4, 5. All right. And then for the placeholders, I'll just put zeros. Obviously, we can't have a negative in the middle, so that negative will be carried to the beginning. So this will be a negative 0.00000176. And that's your standard form. All right, let's look at number 50. You're given negative 912 million. And we want to convert to scientific notation. So in this case, again, this part right here has to be the absolute value of it has to be between the numbers 1 and 10. So what I'm going to do is I'm going to take the decimal that's right here, and I'm going to move it until I get it to a point where the number is between 1 and 10, positive or negative. So here we go. So that's going to be 1, 2, 3, right? 1, 2, 3, yep. 4, 5, 6, 7, 8. So again, that's 1, 2, 3, 4, 5, 6, 7, 8. So that means that my number is going to be times 10 to the positive 8th power. So when you are going from standard to scientific and you move left, then this is going to be a positive, because you got to think backwards. So if this was a positive, I would want to move that decimal to a right to get the correct answer. All right, so in this case, that would just be negative 9.12. So you just write out the rest of the numbers as the number. So again, the number has to be between 1 and 10. It's a positive number, because if I was to rewrite this, I would move this decimal. So if it's positive, I would move decimal to the right, and it would end up back to this answer. So when you're converting, if you're unsure if you wrote the right sign, work it back out the other way and see if you get this answer you started with. Let's look at number 51. You're given 0. 6 zeros. 1, 2, 3, 4, 5, 6, 2, 1. And we want to convert this to scientific. All right, so again, take that decimal, move it until you get a number that's between 1 and 10, positive or negative. So 1, 2, 3, 4, 5, 6, 7. So that's going to be times 10 to the 7th power. But notice this is a decimal, so it'd be negative. So that when I rework it out, I would have to move the decimal to the left. And then the number that I'm left with is 2.1. Again, that's a number that's between 1 and 10. All right, so look at number 53. 53 is 5,100. And we want to convert that to scientific. Just because it's a smaller number does not mean you can't do the same process. Take the decimal, move it until you get a number that's between 1 and 10, positive or negative. 1, 2, 3. So that's going to be times 10 to the 3rd power. And again, that'll be positive. So now work it back out, it'll go to the right. And so therefore, that would just be 5.1 times 10 to the 3rd power. Let's look at 54. 54 is negative 0.000187, and we want to convert this to scientific. So again, I'm going to take the decimal and move it until the number is between 1 and 10, positive or negative. So that's 1, 2, 3, 4. So that's going to be times 10 to the 4, but it's going to become negative 4 because to go back in the order I need to go left. And this would just be negative 1.87. All right, let's just do one more to make sure you have plenty of examples. Let's look at 55. This one is 3.12 times 10 to the 2nd power. Actually, I wrote that wrong. And this time I want to convert it to standard form. Again, it's a positive number, so again, I move it to the right that many times. So that's going to be 1, 2. So in this case, that number turns into 312 and 12. So it's 312.12. There you go. And that's pretty much what 1.3 is. So as always, if you have more questions, feel free to email me. Until next time.